In July 2025, telescopes caught something moving through our solar system that came from another star entirely, only the third object like it ever confirmed. Within weeks, its chemistry looked wrong for a comet. Its trajectory triggered a genuine planetary defense test, and one Harvard astronomer publicly asked whether it might not be a comet at all. This is the real story of 3I Atlas, and the actual data is stranger than most of the headlines let on. On July 1st, 2025, the Asteroid Terrestrial Impact Last Alert System, a network of survey telescopes designed primarily to spot dangerous near-Earth asteroids, picked up a fast-moving object out near the orbit of Jupiter. Within a day, the Minor Planet Center confirmed what its trajectory and speed already strongly suggested. This wasn't a solar system object at all. It was moving on a hyperbolic path, meaning it wasn't gravitationally bound to the sun the way every planet, asteroid, and periodic comet in our solar system is. It came from interstellar space, would swing through our solar system exactly once, and would then leave again, forever. Astronomers named it 3I Atlas, the third confirmed interstellar object ever detected, following Oumuamua in 2017 and Comet Borisov in 2019. Discoveries like this are exceptionally rare precisely because of how narrow the detection window is. An interstellar object only becomes visible to our telescopes for the relatively brief stretch of time it spends passing through the inner solar system, often just months, before it fades back into darkness and distance forever. Oumuamua was spotted only after it had already made its closest approach to the sun and was on its way back out, meaning astronomers never got a clean, extended look at it. Borisov gave researchers a somewhat longer observing window. 3I plus Atlas turned out to be the most thoroughly observed of the three by a wide margin, discovered while still several months from perihelion, giving astronomers around the world enough lead time to point some of the most powerful instruments ever built directly at it before it disappeared again. From the very start, 3I Atlas behaved like an active comet, developing a coma, the bright cloud of gas and dust that surrounds a comet's icy nucleus as sunlight warms it. That alone made it only the second confirmed interstellar object, after Borisov, to display this kind of clear cometary activity. Oumuamua, by contrast, never showed a visible coma at all, which is part of why its true nature is still debated today. Early observations estimated the nucleus of 3I Atlas somewhere between roughly 440 meters and 5.6 kilometers across, a genuinely wide range that reflects just how difficult it is to measure the solid core of an object hidden inside its own cloud of outgassing material from tens of millions of miles away. If watching how astronomers actually pin down the truth about a genuinely alien visitor using real telescope data rather than speculation is exactly the kind of story you come here for, go ahead and subscribe, because we cover discoveries like this one as the real data comes in. Here's where the story gets genuinely strange, in a way that's fully backed by published, peer-reviewed data rather than speculation. In August 2025, the James Webb Space Telescope turned its NIR-spec instrument on 3I Atlas and found something unusual about its chemistry. Most comets, as they warm approaching the sun, release gas that's dominated by water vapor. 3I Atlas's coma was overwhelmingly dominated by carbon dioxide instead, with a carbon dioxide to water ratio measured at roughly 7.6 to 8 to 1. Among the highest ratios ever recorded in any comet, solar system, or interstellar. Researchers found this reading sat more than 4 standard deviations above the normal trend astronomers expect based on how far a comet sits from the sun, a genuinely significant statistical outlier. Alongside the carbon dioxide, the same observations picked up water ice, carbon monoxide, and a tentative trace of a sulfur-bearing compound called carbonyl sulfide. Researchers have offered a fairly mundane, well-grounded explanation for why the chemistry skewed so heavily toward carbon dioxide rather than water. One leading possibility is that 3I Atlas simply formed farther from its parent star than most comets in our own solar system did, in a region cold enough that carbon dioxide ice could accumulate more readily relative to water ice. Another possibility researchers are actively testing is that billions of years of exposure to cosmic radiation during its long journey through interstellar space may have altered the outer layers of the nucleus in ways that suppress water outgassing relative to carbon dioxide when the object finally warms near a star. Neither explanation requires anything beyond ordinary, well-understood cometary physics, just physics operating on a body that spent an extraordinarily long time drifting through an environment far colder and far more radiation-soaked than anything in our own solar system. Follow-up observations kept adding to the picture. A separate NASA instrument called SphereX detected a wide, resolved cloud of carbon dioxide gas, along with strong water ice absorption in the comet's spectrum. Later, once the 3I Atlas had swung around the sun and was heading back out of the solar system, Webb's mid-infrared instrument caught something else entirely, a robust detection of methane, along with a faint trace of nickel showing up in significant quantities only after the comet's closest approach to the Sun. Because solid methane sublimates, meaning it turns directly into gas at a much lower temperature than carbon dioxide does, its delayed appearance raised genuinely open questions among researchers about the comet's internal structure and thermal history, questions that remain part of ongoing analysis rather than settled science. Then, in 2026, researchers published something that turned out to be the most scientifically important finding of the entire encounter, an isotopic analysis of the water and carbon dioxide 3I atlas was releasing, published in the journal Nature. Isotopes are versions of the same element with slightly different atomic weights, and the specific ratio between them can act almost like a chemical birth certificate, revealing something about the environment an object originally formed in. The water inside 3I atlas turned out to be enriched with deuterium, a heavier form of hydrogen, at a level more than 10 times higher than in any comet ever measured inside our own solar system. Its carbon isotope ratios similarly fell outside the range seen in solar system comets, and even outside ratios typically observed in nearby interstellar clouds and the planet-forming disks that surround young stars elsewhere in the galaxy. In plain terms, this object is chemically unlike anything that formed here. Hard, physical evidence that 3I atlas really did originate around a different star system entirely, likely in a colder, more distant environment than where our own solar system's comets formed. This is precisely the kind of finding that makes interstellar objects so valuable to planetary scientists in the first place, regardless of how strange any individual result looks on the surface. Every planet, moon, asteroid, and comet native to our own solar system shares a single common origin, all formed from the same collapsing cloud of gas and dust roughly 4.6 billion years ago. And Interstellar Visitor is the only kind of object that lets researchers directly sample material that formed around an entirely different star, without needing to build and launch a spacecraft capable of traveling there itself. Every measurement taken of 3I atlas, however small or technical it might sound, effectively functions as a free close-up data point about the chemistry of planet formation happening somewhere else in the galaxy. Combine that chemistry with the object's extraordinary speed, and you get a sense of just how old this visitor might actually be. 3I atlas crossed the inner solar system at roughly 130,000 miles per hour, the highest velocity ever recorded for any object passing through our solar system. A speed consistent with an object that has been drifting through interstellar space, unbound and unhurried, for an extraordinarily long time. Based on its trajectory and composition, some researchers have suggested 3I atlas could be several billion years older than our own solar system, potentially making it one of the oldest individual objects ever directly studied by human instruments. Here's where the object's path actually intersected with Mars, and where the real story diverges sharply from anything resembling a collision. On October 3rd, 2025, 3I atlas made its closest approach to Mars, passing at a distance of roughly 29 million kilometers, about 18 million miles. That's not a near miss by any reasonable definition. For comparison, that's well over 70 times farther than the distance between the Earth and the Moon. But that distance turned out to be scientifically valuable in an unexpected way. The European Space Agency's ExoMars Trace Gas Orbiter, already in orbit around Mars for an entirely different mission, turned its instruments toward the passing comet and captured it from an angle no Earth-based telescope could match, roughly 10 times closer than ground observatories back home. Combining that Mars-based observation with data gathered from Earth allowed astronomers to sharpen their prediction of the comet's path by a factor of 10, dramatically shrinking the uncertainty in exactly where 3I atlas was and where it was headed next. ESA has described this specifically as a valuable real-world test case for planetary defense, demonstrating how spacecraft already stationed around other planets could someday help track a genuinely hazardous object faster and more precisely than Earth-based telescopes working alone. It's worth being completely clear about what that test case was and wasn't. It was a demonstration of tracking technique. It was never a response to any actual danger because 3I atlas was never on a trajectory that threatened Mars, Earth, or any other body in the solar system at any point in its passage. The engineering challenge behind that Mars-based observation is worth appreciating on its own terms too. The cameras aboard ESA's Trace Gas Orbiter and Mars Express were built and calibrated to photograph brightly lit terrain on the Martian surface from a stable, predictable orbit, not to track a small, faint, fast-moving object roughly 30 million kilometers away, while the spacecraft itself continued its normal orbital motion. Mission engineers had to carefully calculate exactly when 3I atlas would pass through each camera's narrow field of view and compensate for the orbiter's own movement during the brief window of opportunity, all for an object that was, from Mars's vantage point, little more than a faint smudge of reflected light. That the images came back usable at all reflects a fairly significant improvised engineering effort layered on top of hardware never designed for this specific job. That close pass by Mars also produced one of the more remarkable image sets of the entire event. NASA's Mars Reconnaissance Orbiter photographed the comet using its high-resolution camera, and just 2 days later, the Perseverance rover, sitting on the actual surface of Mars, captured its own image of 3I Atlas using its Mastcam-Z instrument, the first time an interstellar object had ever been photographed from the surface of another planet. Around the same period, NASA's Lucy spacecraft, en route to study asteroids near Jupiter, and the Psyche spacecraft, on its way to a metal-rich asteroid, both captured their own independent images of the comet as it passed through their respective fields of view, giving researchers an unusually wide array of vantage points on a single object. 3I Atlas reached its closest point to the Sun on October 29th and 30th, 2025, passing at a distance of about 1.4 astronomical units just outside Mars's own orbit, meaning it never came anywhere close to the Sun's more intense heat the way many comets do. It then made its closest approach to Earth on December 19th, 2025, passing at a distance of roughly 1.8 astronomical units, about 167 million miles, farther from Earth than Mars ever gets at its closest. Around the same window, two X-ray telescopes, XRISM and XMM Newton, observed a faint, diffuse X-ray glow surrounding the comet's nucleus, making 3I Atlas the first confirmed interstellar comet ever observed in X-ray light, one more genuine first added to an already unusual object's resume. Now, let's address the part of this story that actually did generate real, if narrow, scientific controversy, because it deserves an honest, careful explanation rather than either dismissal or exaggeration. Avi Loeb, a Harvard astrophysicist well known for previously arguing that the interstellar object Oumuamua might have been artificial in origin, published a series of papers and public commentary raising the possibility that 3I Atlas's unusual characteristics, its extreme speed, its atypical chemistry, and its trajectory passing unusually close to several planets, could theoretically be consistent with a technological origin rather than a purely natural one. Loeb was explicit that this was a low probability hypothesis he believed was worth testing against the data rather than a confident conclusion, and he framed his papers as an argument for gathering more observations rather than a claim that the mystery was already solved. It's worth understanding Loeb's actual scientific position a bit more precisely because it's often flattened into something more sensational than what he actually argued. His papers pointed to a handful of specific checkable claims that the trajectory happened to pass unusually close to several planets in succession, that the object's brightening and subtle course changes were worth modeling carefully against known outgassing behavior, and that an object this old and this fast deserved the same rigorous scrutiny any anomalous data point would get in any other field of physics. He explicitly stated throughout that the most likely explanation remained a natural comet, and that his role was to make sure the technological hypothesis got tested and ruled out with real evidence rather than dismissed purely on the grounds that it sounded implausible. The overwhelming majority of astronomers studying 3I Atlas, including the teams operating Webb, Hubble, ESA's Mars orbiters, and the ground-based survey network that discovered it in the first place, evaluated the same data and reached a very different caused by that outgassing pushing against the nucleus, like a very weak natural thruster, and its isotopic fingerprint matched what's expected from an unusually large, unusually old, and unusually carbon dioxide-rich comet, not anything resembling engineered technology. Non-gravitational acceleration, the kind of subtle trajectory nudging that comes purely from gas jets venting unevenly off a rotating icy body, is a well-understood and thoroughly documented phenomenon in ordinary solar system comets, and researchers who modeled 3I Atlas's own small course changes found them fully consistent with exactly that kind of natural outgassing, not any form of deliberate propulsion. It's genuinely worth appreciating why this particular disagreement got so much public attention, because it says something true about how science actually works in real time. A credentialed scientist raised a testable, falsifiable hypothesis in public using real data, rather than pure speculation, and the broader scientific community responded not by silencing the question, but by continuing to gather more observations, more spectra, more isotope measurements, and more trajectory data until the evidence became overwhelming enough to settle the matter. That process, open disagreement followed by more data followed by consensus, is precisely how science is supposed to function, even when one voice in the conversation turns out to be pointing in the wrong direction. By the time 3I Atlas finished its brief tour of our solar system, the picture assembled from real telescopes and real spacecraft was already remarkable enough without needing any embellishment. A comet older than our own solar system, carrying a chemical signature unlike anything ever measured in a solar system object, moving faster than any visitor ever recorded, passed close enough to Mars to become an unplanned test case for planetary defense tracking, close enough to multiple spacecraft to be photographed from more independent vantage points than almost any comet in history. And it did all of this while never posing the slightest actual threat to any planet along its path. 3 Eyes Atlas is gone now, already faded from view, racing back out into the interstellar space it came from and will never return to. What it left behind is a genuinely valuable data set, hard evidence about how objects form around other stars, real-world proof that spacecraft already stationed around neighboring planets can meaningfully sharpen our tracking of anything unusual passing through, and a clear, well-documented example of how scientific speculation, however headline-grabbing, ultimately gets tested against evidence rather than simply repeated into legend. It's also worth sitting with just how much genuine science came out of an object most people only ever heard about through wildly exaggerated online claims. A real interstellar visitor, one of only 3 ever confirmed, got observed by Hubble, Webb, Spherex, 2 separate X-ray observatories, multiple Mars orbiters, a rover on the Martian surface, and 2 spacecraft en route to entirely different destinations, producing peer-reviewed findings about its chemistry, its age, and its likely origin around another star. That's an extraordinary scientific haul from a single object's brief, one-time pass through our solar system, and none of it needed any invented drama to be worth paying attention to. If deep dives into real, carefully sourced space discoveries, the kind that turn out to be genuinely strange without needing anything invented, are what you come here for, make sure you're subscribed, because there's more of exactly this kind of story on the way. And if this real version surprised you more than the viral rumors did, let me know in the comments, and I'll see you in the next one.